Hello students. In this video, we're going to dive into the fascinating world of metals and non-metals. These two groups of elements are essential in our everyday lives, and each has its unique set of properties that define how they behave and where we can find them. Let's start with metals. One of the most striking features of metals is their shiny appearance, a quality we call luster. Think of shiny objects like gold jewelry or polished silver. They're both excellent examples of metals with high luster. Another property that makes metals special is their malleability. This means that metals can be hammered or pressed into thin sheets without breaking. A simple example is aluminium foil. You might also notice that metals can be drawn into thin wires, a property known as ductility. Copper, which is used in electrical wiring, is a perfect example of a metal that showcases both malleability and ductility. Metals are also excellent conductors of heat and electricity. That's why you see copper used so widely in electrical circuits. Additionally, metals have a property called sonority, meaning they produce a ringing sound when struck. Think of the sound of a bell or a tuning fork. Those are metallic sounds. One more thing to note is that metals are typically dense, meaning they're heavy for their size. This gives them strength and makes them ideal for construction and manufacturing. Most metals also have high melting and boiling points, which allows them to withstand high temperatures. Iron, for instance, can endure extremely hot environments. Finally, most metals are solid at room temperature, although there are a few exceptions like mercury and gallium, which are liquids. Now, let's turn our attention to non-metals. These elements have a completely different set of properties compared to metals. Unlike the shiny luster of metals, non-metals tend to have a dull appearance. They also lack the malleability and ductility of metals. Instead of bending or stretching, non-metals are brittle and can easily break or shatter under pressure. Sulfur and phosphorus are good examples of brittle non-metals. Non-metals are also poor conductors of heat and electricity, which is why they aren't used in wiring or cookware like metals are. Another key difference is that non-metals don't produce a ringing sound when struck, so they aren't sonorous like metals. In terms of density, non-metals are generally lighter than metals. For instance, gases like hydrogen and helium are very light, much lighter than any metal. While most metals are solid at room temperature, non-metals can exist in various states. Some are solid, like sulfur, others are liquid, like bromine, and still others are gases, like oxygen. Now, let's compare the chemical properties of metals and non-metals. When metals react with oxygen, they form metal oxides. This process is called oxidation. For example, when magnesium reacts with oxygen, it forms magnesium oxide. Some metals also react with water. Sodium, for instance, reacts vigorously with water to produce sodium hydroxide and hydrogen gas. Similarly, metals can react with acids, like when zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. Metals can also react with bases, producing hydrogen gas in some cases. They are involved in displacement reactions, where more reactive metals can displace less reactive metals from their compounds. An example of this is zinc displacing copper from copper sulfate. Additionally, metals can combine with non-metals to form compounds, like sodium chloride, which we commonly know as table salt. Metals also have the ability to form alloys, mixtures of two or more metals, such as brass, which is made from copper and zinc. However, metals are also prone to corrosion. When metals like iron react with oxygen and water, they corrode, forming rust. Non-metals, on the other hand, behave differently when it comes to chemical reactions. For example, when non-metals react with oxygen, they form acidic oxides. Sulfur, when it reacts with oxygen, forms sulfur dioxide, a common acidic oxide. Unlike metals, most non-metals don't react with water or acids. However, some non-metals may react with bases, though this is less common. In our everyday lives, both metals and non-metals play essential roles. Metals are used in construction, transportation, electronics, and even cooking utensils. Non-metals, on the other hand, are crucial for life processes. Oxygen is vital for breathing, and nitrogen is a key ingredient in fertilizers. The extraction of metals from their ores also varies depending on the reactivity of the metal. Highly reactive metals like sodium require methods like electrolysis for extraction. Moderately reactive metals, such as zinc, often need roasting, while less reactive metals, like copper, can be extracted simply by heating. To sum it all up, metals and non-metals each have their own set of unique properties, and understanding these differences helps us see how they contribute to both technology and nature in different ways. Give this question a try now. What is the term for the substance created when metals oxidize? Please share your answers in the comments. The complete curriculum for Class 8 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.